name is Sachin. I work for Oracle OCI Cache team, and I'll be presenting the Valkey quota module. So what is this about, right? So wherever there's multi-tenant, multi-users, multi-services that are using Valkey, a lot of performance issues, a lot of other issues that we hit because there's one tenant that's hogging up the connections or the read rate or the CPU or something with Valkey, right? So how do we protect Valkey against tenants, and how do we give fair shares to everyone? Okay, so let's talk about the problems that we face. One is resource exhaustions. So let's say you set the max connections to 1,000, and then you have multiple microservices using it, and one microservice just went down and it came up and it starts to connect, and it goes to, and it uses all the 10,000 connections, right? So, and that's bad. The other service can't use Valkey anymore. 100 hertz, like I said, the one app crashes, it came back up, it starts to basically have connections down towards, right? That's bad. One tenant is reading a lot or writing a lot. Unfair pressure on the server. So the goal is to fairly allocate across all of these, fairly allocate connections and read rates and write rates across all tenants. What we have now, we have Access. Access is great. Access is good for security, but what's missing is there is no way of the gap is that there's no way of making sure these active users can be restricted in any way, not to hog resources. Let's get into this module. Let's get into the module. So how do we limit connections from connection storm, and how do we limit write rates and read rates? It's a basic sliding window approach. So this is integrated directly into Valkey, so there's no latency issues. Of course, log all of it, we into the info command. So into the info command. So you always have idea on what's happening, and you can always take the dashboards, so you know what's happening. Okay? The architecture, how it works. So we have the quota sidecar. So we can't integrate this directly into Apple. That will need me to make changes to the Valkey core code. This is just a module. So it's basically another configuration file that you can have. I can show you how that looks like. So it's just this, right? So you can have the user one that has what's the maximum number of connections the user one can have, what's the read RPS the user can have, and then what's the write RPS the user can have. And then there's another field called connect RPS. If you see here, that's basically the connection rate per second that the user can have, right? So that's the quota sidecar. How does it enforce that Alice can have only 2 connections out of the 10,000 connections or of the 1,000 connections? So every time the auth callback happens, it checks how many connections has Alice made. It keeps an in-memory bracket, and once it sees that she is exceeded 2, it just doesn't allow. It does a disconnect on that client. And then how does it enforce read and write RPS? A command filter. It keeps a count of how many commands that user has ran over the last second, and if it goes past it, it basically stops them from reading or writing after that. And so let's go to the scenario 1 into the live demo, right? So scenario 1 is I talked, like Alice has a cap of 2 connections. She should not be able to connect more than that, right? And how can we see that is, let's say out of the server capacity 1,000 here is the max number of connections, and let's say so if I click on Alice limit demo, it's going to make 2 connections. You can see the live clients is 0 for now, and then the maximum connections that Alice can make is 2, right? And if I click on Alice, you can see Alice has 2 live clients. This is basically client list that you can see here, client list command. But then if I click on Alice a couple of more times, you can see the error come here saying, yeah, the connection quota exceeded for Alice, bucket Alice, and she can't connect anymore. And it resets, but yeah. Next scenario, right? How do we ensure latency, and how do we ensure that we don't interfere when we don't give connection RPS? How do we ensure that those guys that don't get interfered with this module? It does not even like auth just seamlessly flows, and that's I think the part of the Rust SDK and how Valkey itself is built. So if I click on Charlie burst connections, he makes 120 connections with 0 latency, right? You can see 120 connections of Charlie was made. He does not have any connection RPS. He does not have any read RPS, write RPS, and he has 120 connections made. Moving on. Now you can get the read burst, the read rate. So if he set Alice's read rate to 3, then every time any read command, it can be get, any of the commands that come under the read bracket is going to get rate limited. And the way we can see that is if I click on Alice read burst, you can see Alice has a read rate of 3, and you can see that Alice's read never went over 3, right? And if I keep clicking it, I can keep increasing it. It'll always be at 3, but it's never going to go past 3, right? So that's about the read RPS. And then the last scenario we have is what if an app goes down and it comes back up and it basically calls the connection stop? That's bad too. And then we can enforce connection RPS. So you can see Bob has a connection RPS of where's Bob? Yeah, here's Bob of 10, and then I calls a connection stop from Bob. I keep clicking it. He's never going to make more than 10 connections a second, right? And see that you can see the quota exceeded for Bob in the logs. This is just another slide to talk about it. Yeah, it's stable. It gives you fairness, fair share to all the multi-tenants when you have multi-tenant architecture for using Valkey, and it gives you peace of mind and better ops. Any questions?
Especially with setting up a connection or with TLS connections, setting up a connection is a lot more expensive than maintaining it. So by the time you get the auth, you've already gone through the whole setup process. If you reject a connection, there's nothing to prevent the client from just reconnecting immediately, right?
Can you repeat the question for that? So that's probably better. You're right.
So with TLS connections, the expense is in the connection setup. So if the client sets up a connection and then you reject the connection and do the auth, there's nothing to prevent the client from immediately reconnecting and burning those resources.
That is true, but we can always cap them at how many times they can retry a second, right? So
how do you know that until you do the auth, right?
It's at the auth callback. I never actually go ahead with the auth. At the auth, before the auth even goes forward, I check, is he at cap? Is Bob at cap? So, the further, so the way the auth callback works in the Rust SDK is you can basically hijack the auth command, right? And you can have your own flow of how auth works. And I don't even let auth happen, and I check the connection limit before that, and then I let the auth happen.
Right, but the connection establishment happens before the auth. So you've done the full TLS negotiation before you ever get to that point, right?
That's true, but this is it has its limitations.
Okay.
So when you're rejecting a connection or throttling them in some way, do you send an indication to the client so that they can retry after these many milliseconds or something?
Not as of now, but that's a good idea to add to the module. As of now, it's just a log message that we have on the Valkey logs, but yeah, we could add some kind of error code or something that You can tell the client to retry after these many seconds, or you're being late, like basically a 429 and with something.
Hey, I might have missed it. Is it open source?
Not yet. I can't. I'm going to make it soon.
Okay, thank you.
Yeah.
Out of curiosity, have folks had problems with these kind of like noisy neighbors? Sorry. It's a question. You know, we all operate lots of cache clusters and servers. Because we've had a lot of issues, like when one customer starts hogging connections to the same, basically multi-tenant applications, right? The same. Here. And a lot of this basically based on the experience we've had where, you know, you have one cache shared by multiple applications and one application starts hammering the cache and other applications are unhappy, or and customers call and complain and we try to educate them on this, but sometimes they can't quite implement the functionality necessary to do this appropriate rate limiting in their own application code. So we've been experimenting with various things, how to essentially create these multi-tenant caches. So like last year, I published a blog on our website where we talked about how we track metrics for different users. And basically we focus on like 4 different things, you know, connections, memory, number of keys. So anyway, and this is this builds on that. So I'm just curious if people experience similar problems. Yes.
What happens when I don't use authentication? I just connect and send it.
Okay. Yes. If it's well, the expectation is customers will disable default user, so then they have to connect as user one,
You can
box,
also-
Alice, whatever.
You could also have connection caps on the default.
Yeah, that's true. Actually, you could cap the default user, but yes, to have connections for specific users, you typically would want passwords. Otherwise, they can just like pretend to be somebody else and connect if the passwords are blank. Yes. Not at all. I don't know. I might hit somebody.
I think it's a good question you're asking, and I think you can safely assume that most of the customers that are coming to Valkey are behind your walled garden, right? So the type of security that you need here is different than one that was like internet facing, where somebody's trying to come in and just cause problems for you. We see this particular problem at Momento with our very large customers for even in single tenant use cases. If you have a very large number of Kubernetes pods and those pods get scheduled or rescheduled and shuffled around, you see a big connection storm happening. You see the same thing happening when auto scaling happens, and suddenly lots of brand new pods show up, and each pod has a connection pool where it needs to make 20 connections to every shard and every replica. So there's a whole lot of network noise, and while that system is kind of healing and dealing with it, the tail latencies are suffering. So it's a problem that we see even in single tenanted use cases with well-intentioned customers. And me being a proxy lover, I'll say proxies do help with that a lot.
Yeah, this is not just a multi-tenancy problem, he's right. We run into this even with single tenant clusters as well.
Yeah, you can have a spike of default
Yeah,
user going
exactly.
from 1 to 100,000.
The problem for us was born with a single tenant user hogging all the connections, and it was bad.
Yeah. And just to point out the thing Khwaja mentioned about the kind of internal customers you'll have are mostly like well-behaved ones. You're not trying to prevent against like Byzantine attacks or other threat vectors. So what really helps is if you can hint them saying, don't try again in these many milliseconds. That's why I was
Yeah.
like checking if you have that.
Definitely makes sense.
That's something that Kafka does, I think, with, for throttling. You can also use that.
Does client support that? We would need client support too.
You would need client support for that. Yeah, I think so.
A lot of our customers have older applications, so and they can be very connection hogs. We've had situations where they would use up all the connections and block our monitoring out.
I was also curious about the metrics you were showing per second, how you were able to pull that.
This is just I have exposed comments that you can these metrics and just pulling it out from that.
So ByteDance opened a PR to the main Valkey repo about having a dedicated admin priority that would supersede everything else. Did you guys look at that at all?
They have an admin port.
It's both an admin port and then they prioritize the connections on those ports.
When did they open it?
A long time ago, like probably over a year ago. They kind of stopped following up on it.
That would be super useful to us because when the connection spikes are happening, our control plane thinks that the node is unhealthy.
Yeah, I think so. What Quadra said is when there's a spike in connections, the monitoring planes think that the node's unhealthy, which as an engineer in last cache, that's relatable.
So you mentioned a special admin port, is that what you're saying?
Yeah, so there's both a special admin port and then when it's accepted on an admin port, it is prioritized. We could prioritize it better, but there's some prioritization.
If I may get on a soapbox for a second, for Valkey's future, I think the issue here is you have just way too many connections that need to be created. And proxies help with that. But there's another thing. The fact that we don't have full multiplexing on the command protocols, like everything is serialized, that forces users and servers to end up needing more connections than they would on a fully multiplex protocol. So a proxy plus a multiplex protocol would meaningfully reduce the need for the number of connections that Valkey needs to serve to begin with.
So Quadra opened a PR or an issue about this and then did not follow up on it. So, well, not you specifically. Dylan did. You should follow up on that. The future of the Valkey project depends on community building. Oh God, so far away.
We gotta do the football.
I'm not gonna throw it, so I'll probably hit you.
Okay, don't throw.
I'm not good at sports. There's a reason I'm in software.
Yeah, this was kind of following up on what Jim was raising. The rate limiting on already opened up connections makes sense because you can then have the read or write or different commands rate limited, but the new connections, at least we've seen this operationally, most of them might even exceed they might even be exceeding limits at the TCP. Like the accept queue itself can you can have so many requests that the server takes too long before it accepts anything and times out. But yeah, I guess there are ways to have error messages returned from new connections being handled or new connections being opened up before you get to the remainder of things like command processing that might handle it at an earlier stage.
Yeah, I haven't looked into that yet, but yeah.
Anybody else?
So this seems like it's module loaded by Valkey, right? Did you consider a proxy that was brought up multiple times? And what are the trade-offs between proxy and the approach you went with?
Maintaining the proxy, I think that's, and I think that would be the first, maintaining the proxy, and because that's another service, a server that you're running. It's another process that you're running. Where this is just like attached to your Valkey, and you can just change these. You can change these quotas on the fly, and you reload it. You can give this feature to the customer as well and to the user, and say you can set it to yourself, and if you're going to break it, you're going to break your cluster. So
Also, when you create users, like you do ACL set user, right? So then you have to somehow get this other information to a proxy that this user has to have this quota.
Unless you maintain the user information only in the proxy.
But then we're completely bypassing all the ACL stuff.
Yes.
It's just filters and callbacks.
Thank you.
All right, thank you. Quick break.
Bio break, anybody? No? All right.
Who's speaking on IBS? Yeah.
We have deal. Have they? You want to try this? I didn't know these. You just wear them and tell them.
Okay. Is it okay to have multiple on at the same time?
Right.
Just join the Zoom, share the screen.
You're gonna do
Oh, there are earpieces here which we like the mic. Hello. Hello.
This one works.
Oh, yours.
Hello.
Yeah. No, these also work. I was just trying to figure out where that sound is coming from.
Okay.
You think the train? First time?
I took it on the front that day.
Oh, wow.
I didn't have to read it.
Oh, really?
Operation.
Oh, that's really nice. Yeah, I was looking at the parking system, but it was quickly just there. Well, like, even with the it's like, then I had this, you'd have to walk 10 minutes from left.
Really, that was the hill you're gonna die on. You could not walk 10 minutes.
Well, that was what made it longer.
Oh, I see. Like I said, like they were equidistant, but once I had walking.
No, I would love the one. Way underneath the building.
The opportunity to
It's like, if I grow, it's let me enjoy this. Yeah.
I mean, I don't think it. I mean, I know everything else that is.
That's why it would be bad. They campaign to make sure the light rail doesn't go.
Hey guys, we got this figured out. Cute little mics.
Yes.
I respond. You want the security? I respond like.
All right, let's get started.
So this is going to be a presentation on Valkey Search that is following up from what we launched last year. There was the 1.0 launch, and in this presentation, we're going to be talking about some of the improvements that have been made since then. For people who are not following Valkey Search too much, it's a C++ module that provides search capabilities in Valkey. So it was added to the Valkey OSS project for users who want to perform searches and still maintain some of the tenets that Valkey provides, like high throughput, low latency. So you can get the speed and scalability benefits. And the big differentiating factor to other search engines is that you can get real index updates. You can get real-time index updates and have your searches available immediately as soon as updates are made on document device. And some of the common use cases here can include things like e-commerce searches, where or even session stores, where I might have a key as the session ID, but there are other attributes that I want to search for, like I might want to search by the device type or the device ID or the user ID or user type. So you get a lot of these benefits. And yeah, this is a quick background. We'll go more into some of the contents of this presentation now.
Sure. Yeah. So this is what we're going to be talking to you guys about today. We'll start with a really quick recap of kind of what was in Valkey Search 1.0. It was focused on vector search, and then kind of high-level architecture of the platform is pretty much unchanged at a high level since then. Then we'll get into overview of the improvements, get into the full text use cases, and get you a nice demo. Followed by actually getting to the low level. So I'll talk about the ingestion side. That was more my focus, and the Karthik was more focused on the search side. Okay, just some of you, I'm sure a lot of you already know. Anyone that's played around with the module, vector search was the focus kind of in 1.0. And just to give some background, like index in general are just like fast and accurate, or ways to provide fast and accurate results as data scales without having to read through all your data. So you can basically do like reverse lookups based on the characteristics of your data and get returned keys whose values contain those characteristics. So vector data is one example of this. You may want to store that in a Valkey vector index and do a similar search on that. And this became quite big in like the AI space because you can extract meaning of different data types, for example, images or like a description, and represent that through filtering through an embedding model as a string of numbers. You can put that in a vector store, then you can find similar vectors. So, I mean, because we're a cache, one like popular example is semantic caching, where you put the result of an LM response, you embed the query as a vector, and then if a similar user asks a similar query in the future, you do a similar search, find that, oh, you already have a similar vector, you have a similar response, just return that, save on GPUs, and then flat HNSW, the 2 times flat being the brute force one, HNSW being the fancy one, takes a little more time to index, but you get the OLOG and search. Okay, yeah, so index creation, this is also an overview.
But all this is doing is FT create command is create an index. So the index is called book index. It's on the hash Valkey data type. We only support hash JSON as ways to represent data that you ultimately stored in an index. You define the key prefix on which you want to ingest data from. So the keys at this prefix will be considered for ingestion. So that's an example. Then you define your schema. Tag numeric vector already existed, but text is the new one we added in 1.2. And then ingestion is quite simple. Just do an H set. So you see here the book. The key of basically the H set is the book : Hobbit. So book : matches. And then the key value pairs of the hash data type will match. The keys will match the names in your schema, and as long as the data is compatible with the find here, it will be ingested. And then, of course, once you ingest it into your index structure, then you can do searches on this, and this is just an example of a quick vector search where you want to find 5 nearest neighbors, the 5 most simple vectors to a query vector. So you can only put one, key in the index. That's just one we just did. Book.
Yes, so these were some of the functionalities that were available in 1.2, and since then we've made a lot of some of the big ones are you can now perform on-vector searches. So previously you were requiring to have a vector in your index and in your queries. So now we can just perform numeric or tag searches independently. So I can search for products in a price range of 0 to 50. I can search for tag or exact match searches like a particular manufacturer. You can do these things independent of vector. This was in 1.1. In 1.2, we have full text now, which is full text search. We can have indexing search on text fields. And both of these, you have a much more expanded hybrid search capability, which means I can perform pretty much searches in a single request, where before you might need to have multiple requests to perform the same type of a query. You can now perform all of this in one shot. Aggregations were added in 1.1, and this is provided with the FT aggregate command. We have single slot indexes and queries, sorting capabilities. The single slot indexes and queries really help you scale horizontally, where you're not limited by fan-out performance. You can add shards and get the performance benefits of scaling out by adding shards and having searches specific to specific shards. And when we're talking about non-vector searches, these are some examples that I was going over. Numeric is a index type that is implemented as a B tree. Tag or exact matches in a ratio tree, and full text, which is what we'll go over in this presentation, is an inverted index that we've implemented through racks. And this is a query here performing a text search with noise and canceling as a prefix search. So you have multiple terms and you have a prefix capability here. So these are the list of operators that we support right now. There's exact term, prefix, suffix, and fuzzy. And all of these will work through the existing composed operators. Like I can have an and that is joining multiple terms, and I can search across. I can search with ORs as well. So I can also have more complex queries that involve nested ands and ORs. We can do negations. And with text, there's also another dimension, which is more of a positional constraint. So rather than just the Boolean result of whether this matches or this doesn't match in terms of checking the existence, there's also positional constraints to say that there's a certain ordering requirement or there's a distance between words that I'm looking for in the documents that I'm searching for. So we get into some of this later on in the presentation, but this is a high-level overview of what we support. For the demo, I'll maybe go over something that we just built as an e-commerce website. I'll probably switch my screen to go over that. Okay, so let's see. This works. Okay, that works. Okay, so yeah, we have a e-commerce website here. This is just a sample one where I have a search bar and a bunch of filters. I can perform text searches through this. I can also filter by tags or exact match tags, which are brand and color. So yeah, and this is backed by Valkey Search. So I have this running over here. So these are some of the searches I did in the past. So yeah, we're using Valkey Search to handle a lot of the searches that are done from this bar. So I can search for something like breathable running shoes. And you can see that these are some of the results I get. They contain the terms that I search for. I can also use pagination here. And in each next page button, I'm fetching the next 18. So this is done using the limit and offset. So yeah, I can also search for things like weightlifting shoes. I can filter by tag and by color. Maybe let's see if there's anything here. Okay, okay, there's not. Okay, so I have something here which is matching with the brand. It's weightlifting shoe, and I can also. So you can see that some of the performance really changes based on how many matches I get. So if I search for something that's more unique and filters here, I can get some of these. I can search results for some of the queries here that have less matches, and this is pretty much what you can do. This is one way an e-commerce customer might be using Valkey Search. So yeah, I guess I'll go back here. And yeah, we talked about a few different types of searches. Some of the other use cases with aggregation can be looking for the top trending content or the top performing items. So you can use this for summarizing and analyzing results. With hybrid searches, I can combine multiple aspects. I can also have text with vector searches as well. With fuzzy, I can get typo tolerant searches. And we talked about the main differentiating factor, which is the real-time lookups. So for customers who need to look at inventory or transaction records, they will be able to do this in real time, which makes which very much unlocks a lot of use cases that have this requirement.
Yeah, we'll get into the indexing logic in a sec, but we're able to index small batches very frequently, which we played around with some of the other solutions like Canopy, which is based on Lucene, and just didn't work for use cases. More built for you have a huge batch of updates, and then you put that into your index. If you want like super frequent updates, small batches, and then search that immediately, this is kind of a great use case for us.
You get this read out consistency as well with so through these some other use cases include semantic caching and agentic memory. For example, we'll probably get into more of this later on with different types of commands.
Cool. Okay, I'll get into kind of the indexing side of things. How do we get the data process and then into the text index. So for the processing side of things, it goes through, well, it's just tokenized, normalized, stop words we don't care about, removed, and then by default, we'll stem the words to their root. So tokenization is very simple, just how you delimit tokens with white spaces and punctuation. We have this default set, but you can also specify it as you want with the punctuation command argument on ftcreate. Normalization. So right now, the only default learned language, say we have native support for. Is that me? Yeah. Let's just. Okay. There you go.
Keep this here.
So
Yeah, this one's.
I'll just talk about it. Okay. Yeah, so it's saying the only language we natively support right now is English. One of the biggest, thing about the roadmap is multi-language support. So we want better support for a huge variety of languages, really. We have customers requesting up to 14 just from one customer. So for normalization, yeah, by default, I mean, English is, of course, just lowercase and capital letters mostly, but by default, we still run it through an ICU library if it contains non-English characters. So cafe, French with an accent aigu on the E, that will be normalized to just a normal to us, E. Stop word removal. Yeah, this is basically words you probably don't care to search for. So, common pronouns, bridge words. This is just going to take up space in your index, use memory, and probably muddy your results. If you do a prefix search and you start hitting into, for example, or in there or something, you don't really care about that, obviously. But you do have the option if you want to create the index with no stop words, which means no stop word removed. Essentially, no words are going to be removed at this stage of the processing pipeline. And once again, we're trying to make it very flexible, so you can define your own stop words if you want. Stemming. Okay, yeah. So stemming, we use a snowball stemmer. I think this is like pretty popular across the industry from the little research I did. It uses an algorithm based on sort of the language structure and isn't always the best at understanding the semantics of the word. Although they do strive to have words with completely different meanings, but with a similar prefix, not stem to the same thing. I think the example is like, as in like awestruck and awful, they don't want that stemming to the same root. But for example, the happiness case, both have the same stem. Happier, you might also think has the same stem, but they kind of err on the side of not overstemming. In this case, actually just there's no root, it just stems to itself. Yeah, so the main reason we do this is it broadens your search results. It matches intent a little bit more. So if you search for happy, maybe products with happy in the name, and you find a product with happiness, well, that's probably not a bad thing for most use cases. That's kind of what you want. And the way we do that search is we maintain the mapping of stems to their variants. So that's how when you have a query, we take the tokens, the words in the query, we apply stem to that, and then we look that up in our stem tree, and we find the variants and do a search on those words as well. Once again, customizable. You can turn off if you don't want, and that some of these other ones I mentioned were just at the index level, but you can have multiple text fields in your index. And for some reason, I remember why you put no stem at the field level. So each text field can have it with stemming. And min stem size is just another option to control, which word you want stem, because really small words kind of doesn't really help in that case. All right, so we've gone through the processing and we're through the pipeline. We have this output from that example I was using. It's just red, run, cat, search, run. And then the next step is to actually put that into a text index. And that text index structure is essentially at a high level just a mapping from tokens to keys and then to the positions at which those tokens appeared in the keys data. Right, so let's see. The prefix tree, we use racks or a modified version of racks essentially. That's going to contain the tokens. I kind of visualize it on the left side here. Part of the reason why I do the prefix tree is you can do a prefix search. So if you did, you know, character R, asterisk, you would then simply, you can see here, traverse around the subtree starting at the second node. And you find what we call the posings objects for both red and red. The posings objects contain the mappings of the keys to the list of positions that would occur at the keys. So I only have one key here, but you really should see lots of keys. And the reason we have positions is to enable, like sometimes you want to find the key that has the word, but you also only care if that key has a word in a sort of order with another word. So the relationship positionality between words in that key matters for quite a few search scenarios. What else? Yeah, I guess the suffix tree, we have a suffix tree. That's optional. It's off by default. Like if you want to do suffix search, you can enable it. It's just going to take a bit more memory for the tree itself, but we point to the same postings object. So overhead should be somewhat limited. Okay, now getting into the weeds a little bit more. We differ from kind of the other field types, like text compared to tag or vector. Vector and tag, numeric, they have a separate index structure per field. And remember, like an index contains multiple fields. And I'll try and do that with the terminology because index is a very overloaded term in this project. So you may come or encounter that if you ever look into the code. But anyways, index being the high level structure that contains one or more fields. For text, if there's multiple fields, they don't have individual text index structures. They have this one text index structure at the overall index level. The main reason we did this was text is kind of unique, whereas if you don't specify a field, it will actually search across all text fields within that index. So I think that was the main motivation. We considered having at the per text or the per field level and the global level, but the global level just cleaning up would be kind of a pain. It's really easy. It's just you drop an index, you now just drop the text structure. So yeah, we have that one text index at the index level. And then we also have the text index structure kind of oddly for every single key. And this is because there's scenarios where we want to basically evaluate a search query, a text search query against a specific key. So inline filtering is one case. You're doing a hybrid search with HNSW, vector search. So you're kind of going through the graph, you're looking at a vector, and you want to evaluate, does the key that corresponds to this vector, does that key's text data also match the text component of the query? So in that case, you can just look at the individual keys text index and kind of do the query just against that. I think we could have done it against the main text index structure at the index level, but it's kind of convenient there, and there's other reasons we have it. There's also this main thread evaluation, where we kind of have to reevaluate the key once we get back onto the main thread. And from a logging perspective, like having this separate structure is nice. And then deletion is actually important because when key is deleted, we get a key space notification saying this key has been deleted, but we don't actually know what the contents were of that key. So now that we have a key level text index, we can actually iterate over the prefix string and just collect all the words, and those are the words tokens we need to then delete from our main index level text index structure. So I think in the future, if we augmented the key space notification and we're a bit smarter about, these queries, that we have to apply to just like a specific key. I think we could probably get rid of that, but that's probably an optimization for down the line. And lastly, just because we have this text index structure at the index level that spans potentially multiple text fields, we actually do need to have a field mask with each field mask with each position. And this is just logically, we do like a bunch of optimization. So like we're not actually doing the overhead of for every single occurrence of a token in the text. We don't have a position and a field mask. We do delta encoding variable. They actually have to traverse it from the start. But we optimize small enough, it still gives good time performance. There's also a bunch of locking considerations because I forgot to mention before, ingestion is multi-threaded. We block the responses synchronous for the clients. From the client perspective, that does the H set or JSON set that leads to ingestion. It's synchronous from its perspective, but it's all done by background worker threads. And because we have multiple keys being ingested at the same time to get that throughput up, there's some locking here, which once again, I think that could be on the optimization roadmap.
Yeah, so this is now shifting more into the different types of searches that we support. I've listed out some of the query operators that we support. So there's exact term, exact phrase, prefix, suffix, and fuzzy, and proximity. These are the different query syntax operators. So you can see here that for the prefix, we use a star at the end, suffix beginning. Fuzzy has a design. The part that makes text slightly different is by default, text searches are across all the text fields. You can choose to search on specific text field by providing the field itself in the query string. Like here in the first case, I'm searching for Apple in the description field. And there's two other searches that involve multiple terms. One of them is exact phrase. So if I have query string and then inside that I have double quotes containing the sequence of tokens, then this is an exact phrase. So it will search for the documents that in these terms in this exact order and with a slop of zeros. So slop means that there should be no extra words in between these words provided in the query. And with proximity and you have the option to then override these properties. So I can choose to have slop but not in order, or I can choose to have in order and slop, but I can choose a slop value which I want. So in this case, you can see that I shortened this query. So I just said great folks from equal to grow, and this slop of true. So it's going to match a document that contains what we have in the first search, since there's a distance of 2 between them. And we've also extended the FT search and FT aggregate commands to support some new command arguments like verbatim, slop, and all. At a high level, the search algorithm is using heapify iterators that merge the postings list that run and over, which pretty much map terms into a list of keys that contain them. So there's merging, which takes place through these iterators, and then we find documents and we validate position constraints. Earlier on, I was talking about the query string, and we have to first parse this into a query syntax tree before we get into the search logic. This is currently done on the main thread and using recursive descent. So I can over here I have an example of a query containing wireless earphones with active noise cancelling, but using a few different operators. Over here, you can see that there's fuzzy, there's also prefix, and then they're all wrapped inside a compose and predicate. We also you can also see that there's a distance of 1. So with fuzzy, you can have a distance specified by the number of percentage symbols. And here there's a distance of 1. So we will use this in the fuzzy Levenstein algorithm that we implemented. But the query parsing, once we detect that it's a text term or it's a text predicate, we go through the same steps that we did on ingestion. And this helps us, this is required for us to match what we had ingested earlier. So we go through the same steps of punctuation-based tokenization, stop word removal, normalization, and then we can classify them into predicates. If it's a term predicate, we will use stemming if the index has stemming in it. And yeah, this is a very high level overview. Let me get rid of that. So let's try to get rid of the thing that was sticking on the screen. Okay, that's okay, I still see it, but okay. All right, no, that's gone now. Okay, so yeah, with the search algorithm, we have this is a rough picture of how a non-record search would look. You get the command, there's query parsing, which I talked about, where we generate the query syntax tree, and then on the background reader threads, we have this. We have some of the rest of the steps over here that take place. We first have to evaluate this query syntax tree itself, and this can contain multiple predicates. Through this, we generate entries fetchers, which pretty much is used for generating a list of keys that match that particular search. We also have logic to limit the number of results that are found, and this can be configured. We have this logic that gives us a list of keys, and we also have optimization paths over here that say that if we have fully solved this query, then just go into the direct iteration and we can return these results. There's also cases where it's not fully solved, and this is mainly where you have numeric and tag, since they're not returning search results in a fixed order. Then it's not fully solved if you have an AND of text of tag and numeric. So there are certain cases where we will go into a per key evaluation, where we evaluate the query syntax tree for those subset of results that we found. And once we have a list of keys at the end of this step, it's pretty much used to just unblock the client. And when we're back on the main thread, if there is no actions, which means that there is no update, just return the results as they are. Yes, so this is getting more into what makes the search possible. So we have the term iterator, which is pretty much a backbone to all the text searches. If your query syntax tree contains text, it's a single word like running. We handle this predicate by generating a term iterator, and this iterator is used across all kinds of operators. So it can be a term search, it can be a prefix or suffix or fuzzy. We reuse the same iterator for all of this. We just need to provide it with key iterators, which are iterators over the postings objects. And we build this term iterator, which will essentially merge key iterators together. So I mentioned earlier that they're deepified, so you have faster lookups, but they follow a contract, and this contract has been implemented across all the text iterators, which is they return results in a sorted order. So we go in a sorted order of the key in terms of the intern string pointer values, and the same thing with positions as well. So if I have a key available, then I continue to I have this other API called next position, which I can keep continuing, and then it helps me iterate over all the positions in all the keys. Proximity iterator is used mainly in exact phrase or approximate lengths. So any type of query that has a positional aspect to it. So that includes slot and in order. We perform these positional checks, and we also ensure that they're in the same field. So in this case, there's 3 tokens that I'm searching for. So we build a composed predicate that contains child iterators, which are term iterators that we talked about in the previous slide. So you can see how we use these term iterators to perform the search using a proximity iterator, and that is kind of shown here. It goes over this. I mean, at a very high level explanation, we just find the common key among all the terms that I have. If there is no common key, then it means that there is no document that matches it. If there is a common key, then we need to get into validating the positional constraints. So we look at what the next position is for all the terms, see if they match the in order and slot requirements. And if they do, then that's one document that matches. And we continue this to find all the documents that match. This is getting to more complex queries, but you can also perform this in a nested manner. So that you can see how I have an OR inside and so for a query like fail to connect to either cluster, node, or endpoint, we build a proximity and iterator that has term and OR, and an OR iterator. And the OR iterator pretty much follows the same contract of having next key and next position in a sorted order. If any key is, so we just pick we just pick the next key in a sorted order amongst all the term iterators, and then once we're on a particular key, we go in the same sorted order for positions as well. So through this, one other big thing that has been extended is hybrid search, where you can now, as a Valkey user, perform full text, tag, numeric, and vector in a single query. And compared to just a regular vector search, where you have this recall concept, you can improve its precision by ensuring that they match these other dimensions of text. To say that they need to have this type of a text or this exact category in the form of a tag or a certain range of a numeric value. This also simplifies client-side logic and helps prevent multiple round-trip requests that you might have had to do in the past. And aggregations is another quick thing that I can just explain as one of the features that was added in 1.1, but you can use this for analyzing the search results. So I can take the same query string that I would use in FP search, but then with the results I get, I can perform a lot of operations. Like I can group the results. I can sort them by certain attributes. I can also filter. I can have limits, and I can pretty much use this for generating summaries, or looking at what is the top trending content on a particular e-commerce website, or there's a good amount of searches that you can use to generate different types of summaries through this. And as a quick summary of compatibility, this is built as a superset of what you would get on meta search. It is pretty much having the same commands, and it's matching the direct to query string that you can connect to this across all official Valkey clients, some of which are listed here, as well as the compatible clients from other caches. Here are some of the blogs that we go over these functionalities that were added. And they have also listed the release notes here that goes over some of the features in more depth. But yeah, I mean, I think that this is mostly what we have to present. And probably open up any questions.
We do the mic thing.
What is that?
So I've asked this before in a different form, but is there a definitive list of all the features that are in Ready Search that are not yet in Valkey Search? And the reason I ask is because a lot of customers are saying, I have this working, I have this library. And then they try, and I personally tried it, but not with Valkey 1.2, but with 1.0, and a bunch of things don't work because the libraries accept exact Ready Search, full text search, etc. So what's not there yet?
I don't think we have like official list, but I will say that 1.2 is a big step towards that compatibility.
Yeah.
With text being one of the things, but also like we just opened up types of hybrid searches.
Yeah, and I think one of the big things.
I mean, this one's
Oh, that works. Okay. Yeah. Okay. Yeah.
this is where
Okay. Yeah. So one of the big things that we also did in this release is we added full text. We also added some other command arguments and options which clients might use, like wait, for example. We supported that. We were planning to add scoring, but we still accept wait in anticipation if some client library uses that. So yeah, there's definitely a roadmap of features that we are targeting based on what's most requested. Multi-language is one of them. Scoring is another. But yeah, I think what we're doing is we're making the server work in a way that it can accept different applications connecting and providing those options and still work with what we have in 1.2 for now.
To add to that, Dimitri, we do have a list of feature gaps that we have to really search today. We did post that in some of the search and like the marketing meetings. What I can do is put it up in our search Slack working group in that, so we are all aware and like know what we should be working towards. And like Karthik said, like this is like a huge step towards closing in the functionality gaps. There's some of the other things like index management with alias and like all that sort of other smaller capabilities that still remain as a gap that we're looking into.
And again, 100%, this is really impressive. Just that, like from personal experience, I've spent a lot of time trying to debug stuff, and I know a lot of people will feel that pain as well. And if you don't, basically my experience has been is if you don't use one of the higher libraries, if you just kind of write your own K&N queries, it works. But people prefer higher level abstractions.
That's true.
I think if there are such clients or certain libraries that you're using and seeing errors, you can feel free to post them on the channel. I think we have been paying attention to this and trying to add support in anticipation of what we are building in the future. Like scoring was one of them that I remember. But if there are certain things that clients need for it to work, even for basic things like numeric or tag or vector searches, then we can work on making sure that we're able to accept those options.
One of the things that we would love from you is like search is obviously a very broad space, right? Like even going beyond research, there's like open source nesting search, and there's like a lot of niche capabilities that people use to search the data. And the question is like, what are we interested in building out of this subset? And your feedback right now that you just shared on like, because these are some of the things that we're interested in getting back would be like very valuable. Like,
We'll Slack.
When can I have this in Elastic Cache memory store? And,
Working on it.
all of you have been PR trained. But soon, right? Like the answer is soon.
yeah,
Ish.
5 years.
It's much sooner.
For AWS.
Sooner than 5 years.
5 days, 5 weeks, 5 months.
Here, that's a service community.
Very exciting.
Very impressive.
There was some, I remember in the earlier slide, you mentioned that you log the response to the hset command if you're indexing it, right?
Yeah.
What happens if I'm pipelining a bunch of hset command over the same connection and I'm not waiting for the responses from the server, I'm just pipelining.
I think it would still be the responses wouldn't be released. I don't know how.
I mean, why is that different than I just shot a command and I don't care to receive the answer back? Like,
Because
do a
that
file
can
forget.
overwhelm the server.
Was that?
If I'm pipelining commands, I can overwhelm the server. I can DDoS the server that way.
I think, I mean, Ram probably knows the answer to this. I think he was working on some of this
Yeah,
area.
let's do it.
He wants to take the mic.
Sorry, I didn't quite catch your question. You were saying you're gonna send
I have a
pipeline.
connection, I pipeline hset commands. I
Huh.
just keep doing it. I don't wait for the responses from the server. I just keep pipelining.
Yeah, we have an issue right now. The reply can get overwhelmed and it can cross 64 megabytes buffer, even at ingestion side and also reply side. Yeah,
Yeah, I mean, I think
I-
in general, we do have handling over this. Yeah, but yeah.
yeah. We process as a single command. Like I think the query, I think module engine is gonna pick up each query and then like each request as single headset command. But the server is gonna pipeline all the responses. So it falls under the core engine side, how the response delivers to the client. That is pipelining.
Okay.
So we just mutate every command, and the server, the search module just process each headset command, serve your request, and provide the response back to the client. Like it will just append to a buffer, and then the search like the core engine is gonna pipeline the response into the buffer to the client at the end. But if you pipeline continuously, that's a problem. I think we have to optimize at the client
I
side.
don't have any kind of throttling mechanism to
Right now, no.
slow
Yeah.
down the incoming commands.
I think this is a problem even for core. Like if you pipeline faster than the engine can process, then we can get overwhelmed. We have to tune it. I think this is the existing problem, not just for such module.
Yeah, but then your indexing engine is much slower than
Sure.
the core processing hset command.
Sure. Yeah, we don't have throttling at the moment.
Yeah, I mean, we don't have thought, but we do have, I mean, we have awareness of what we're adjusting. For example, we also have protection over aspects like memory, like we're reserving memory for what we are receiving as commands, anticipating how much memory this is going to take on the index.
Okay.
We do that?
Yeah.
Okay.
And with this, you will also have the ability to at some point, I mean, if it's really going to reach an state, then the request will eventually just get ruled out.
Because basically, there are scenarios where kind of this mutation queue can grow quite big. That sounds like an example of that.
Okay.
And that's where this
Yeah.
out of memory handling comes in.
Do you have like a debounce thing where if I update the same item, let's say 100 times, are you gonna re-index it 100 times too?
It will. I think logically, like you can think of there's like a mutation queue until that's actually applied to the index. If you get another update, you kind of just override it in the mutation queue.
Nice.
So it just
Okay.
depends on like if it's the only thing being written, and maybe you're indexing really fast compared to how fast the commands are being sent, then yeah, you might index all of them, but there is some logic, I believe, to not add a mutation queue where you have like 110 mutations for the same queue.
Nice.
What happens when you delete keys? How does index and free up memory?
For text is nice, it gets cleaned up, so you kind of remember the index structure. Yeah, like so we have these postings objects. So the key itself we do that lookup with that per key tax index. So we basically have we've saved all the tokens from that specific key that we indexed. So we look those up, then we go back to the main index and we basically find reverse prefix tree with those tokens, find the posted objects that contain a key. The map that's there. And then if there's no more keys on the posted objects, we clear the posted object is needed. So it's unlike H in a study where if you delete a vector in H in a study, you still have that's how it's configured. Some ways to override, but that's the problem with H in a study. It should be a problem with
And tag in numeric as well.
Yeah.
Okay, so only H in the study is the memory hog.
Yeah, for now, but I think we also, that's another area which we are planning on fixing or improving as well.
yeah, it's definitely it's a known issue.
Any plans to support searching encrypted data, like maybe using homomorphic encryption or anything like that?
Encrypted data, that's
This is first time we're getting that request, so would love to understand more and see what we can do there. But right now we don't have it planned on how to search.
What is the use case when you search encrypted data?
You want to keep your data encrypted because can leak and that backup can leak, for example. We still want to search.
yeah, I guess, yeah, I mean, it makes sense that the data is encrypted, but I'm actually curious about the use case for the search operations. What would they, what like, would you be expecting to search using already encrypted data, or is it?
Search for plain text. So
Yeah. What would the search accept? What would be provided in the search?
So I'm a little fuzzy, or actually, I am not very aware of how homomorphic encryption works. But from what I understand, you send the data encrypted in some way to the server, and then the searching algorithm can perform operations in order to match that data. And then the result that you get can be identifiers or the encrypted data itself. And the use case would be if you have a CRM and you want to look up a customer by their email address, or search by their email address, or search by their last name, but you don't want to leave that data plain text in your Valkey.
Yeah. So the data is encrypted, but the search is also encrypted.
That's how I understand the homomorphic encryption. Yes.
Yeah, I will read up more about this.
Yeah, definitely something we haven't considered.
you want to perform tokenization on it, so I guess you could just encrypt the string and then search it that way, right? Yeah. So it's
But you can't tokenize the string.
Much higher than that.
Good point. You tokenize it before and then.
I mean, yeah, if it's gonna match exactly that.
Oh yeah, exact matching is easy. That's you're matching a hash. I'm talking about partial search.
I mean, if you have generated embeddings for an object and you're storing just the embeddings, that's essentially a one-way hash. And because you can't go from the embedding to the actual item. And you can do, it's a poor man's homomorphic encryption where if you are doing a similarity search and you know that this particular item is similar, but the item itself is encrypted, then you can keep the entire item encrypted, but keep the embedding in clear text.
I don't know if the embedding is like a trap function. I'm not sure if it has security rigor.
If you figure out how to go from an embedding to the full item, you haven't invented infinite compression.
Well, I mean, you can figure out semantics around.
Fair enough. Yeah. That's why I said a poor man's.
Yeah.
homomorphic.
I mean, yeah, I don't know.
You're right.
But
It's not theoretically cryptographically.
Yeah. Yeah. You can get more information about the data sets.
I'm sure security folks. Yeah.
When's the next version coming out?
I think we're right now.
This version too. Maybe restore and last.
Yeah, we're already thinking about what features to include in the next release. So I think it's going to depend on what that includes.
You're thinking like 1.3 or maybe going 2.0 at some point?
Yeah, probably, yeah, we're evaluating both of them. I think.
Anything specific you're looking for?
I'd say 100% compatibility with the radio search. So that's what we just keep hearing. People, yeah, like people saying, I want to migrate. I want everything to
That's
work.
not gonna happen in the next one.
I think they started.
People are like, I don't want to do anything. I want
I
everything
mean,
to work.
yeah, like there are things that people might not ever use, like there's a phonetic search.
Yes.
I mean, there are other types of searches where, yeah, so I guess, yeah, it depends on what. Yeah, I think it makes sense to kind of pick.
Yeah, well, we'll definitely prioritize. I think we want to get, as many use cases.
Yeah. So the problem, all these libraries get built to the radio search API spec, and even if you're not using them,
Yeah.
the library will likely not work. So the alternative is to build Valkey equivalent libraries
We
to do that. Don't depend on some of those ready search features.
API compatible, so unless the library is using. Eventually, it should only be obscure.
Yeah,
APIs.
I would imagine that it would work. It just depends on what they're doing with it. Because like if I'm doing a text search, it's not going to require phonetic searches by default. Yeah, so yeah, it probably depends on how they're.
Yeah, I think sometimes it's just libraries made certain opinionated choices.
Yeah.
Yeah,
And
that could be a problem.
that's
Yeah, we saw that with the weights and scores, and
Yes.
that's why we fixed that. But I mean, as long as there's no other forced options being passed in like that, I'd imagine it should work with 1.2 pretty clean.
I'll try some things.
I don't think that's
Yeah.
Yeah, we've looked at some clients. Yeah.
I think they started development in 2016. So we're playing catch up.
Yeah, it was the first module.
Was it?
Yes.
I didn't know that. Times.
They did also like duplicate some modules, right? So I feel like
There were-
aiming for 100% compatibility with whatever Redis has built in the past, that might not be useful.
Yes.
Might not be the right.
There were a lot of experiments. It was
Yeah.
very exciting, and there was like they did ready search, and there was like JSON, original JSON. Then they built a new version of JSON. Then they started experimenting with like time series and Bloom and other things, and then they sunset some. So
Yeah, I mean, they've also deprecated
Yeah.
the types
It
of
was like-
dialects that
It
they
was
support.
5 different dialects.
Yeah, and then they're supporting one or two of them now. So I mean, I think it makes sense to pick the ones which really make sense for use cases.
fair point.
It won't be too long. Redis will have to be compatible with us.
Yeah.
Great idea.
Hold on, right out my
Special protocol.
Has multiplexing from the beginning. I just want said they have to rename it.
I was also going to add, Dimitri, it is an open source project. You can contribute.
I'm working on the right stuff.
Well, unfortunately, this module is in C++, but
I agree. It's very unfortunate.
I hear the LMs are very good at writing C++ code, though. Actually, they're apparently not.
They're also pretty good at writing Rust code.
They're actually fantastic at writing Rust code.
They're fantastic at writing unit tests.
You know?
And they don't, not a big fan of their testing, but yeah. I feel like they generate too much.
Unit tests.
Yeah.
You can you have to clean them up sometimes. Fair point. It's good to start.
Do much better at generating business logic than unit tests, I would say.
Any other questions? Going once? Going twice?
So
Sold to Dimitri. Yeah, next to see you guys at unlocked.
Yeah, interested presenting in the future meetup, talk to me or Madeline or.
Yes, we need more speakers. We love more speakers. If you are not Amazonian, grab an Amazonian. They have to let you out. You can't just go down to the first floor. And when you go out to the first floor, you should give your badge to the security guard on the left. Any other housekeeping items? No? Okay. Thanks all for coming.